Continuity and differentiability. This is one of the most hated topics in the whole ISC mathematics syllabus. In this video, I am going to cover up the most important MCQs for the upcoming ISC Semester 1 examination so that you score full marks out of this topic. Hello dear, this is Tinku Hor and you're watching Infinity Maths. Here is your first question. Pause the video and give it a try. Question number 1. The function is defined as x square minus 3x plus 2 divided by 4x minus x cube. First of all, we need to simplify the given function. Now the numerator can be factorized as x minus 1 into x minus 2, and the denominator can be factorized as x into 2 plus x, 2 minus x. So after cancelling these two factors, finally we'll get x minus 1 x into x plus 2. So this will be the final expression of the given function. Now from the denominator we can clearly decide that for x equals to 0 and for x equals to minus 2, the denominator is going to be 0. If the denominator is 0, then that means fx is equals to undefined. So there are 2 points of discontinuity for the given function. For x belongs to r minus 0 and minus 2, the function is continuous. So for this question the answer is option B, that is there are 2 points of discontinuity. Here is your question number 2. Again, pause the video and give it a try. In the second case, the function is defined by mod of x minus 1 plus mod of x minus 2 plus sine x. First two cases are containing the modulus function. For simplicity, if we consider the function modulus of x, the graph of this given function is something like this, with the critical point x equals to 0. That means this x equals to 0 is the turning point of the graph, but at this particular point the graph is continuous. There is no breakage or discontinuity in the graph. It is just the critical point where the nature of the graph is changing. Now in case of mod of x minus 1, the nature of the graph will remain the same with a simple change, that is the critical point will shift to x equals to 1 from x equals to 0. But the nature of the graph will remain the same. Similarly, for the mod of x minus 2 function, the critical point of the graph will shift to x equals to 2. But in both the cases, the graph or the function is continuous for all the real values of x. And as we all know, the trigonometric functions sin x and cos x are always continuous for the real values of x. So the combination of 3 continuous function is always a continuous function. So in this case, the number of points of discontinuity will be 0. So option D is the correct answer. Another important type of MCQ. Again, pause and try it yourself first. In question number 3, the function is defined as fx is equals to cot x. Now, the cot x function is not a continuous function, as well as the tan x. In case of tan x, it is 0 at 0, infinity at pi by 2, again 0 at pi, and minus infinity at 3 pi by 2. So for all the odd multiples of pi by 2, the tan x function is undefined. Similarly, the cot x will be just the opposite. It is in infinity or undefined when x is integer multiple of pi, and it is 0 when x is odd multiple of pi by 2. So in this case, that is fx equals to cot x, the points of discontinuity are the integer multiples of pi. That means for all x belongs to n pi, where n belongs to z, or more precisely positive integers 0, 1, 2, 3, the given function is going to be discontinuous. So option A is the correct answer. If the given function was defined as fx equals to tan x, then option D should have been the correct answer. In the next case, the given function is defined as fx equals to tan x. Now we need to find the domain where the function is continuous. So we just need to avoid these values where x lies, or x is equals to the odd multiple of pi by 2. Other than for all the real values of x, the given function is continuous. So real number minus the odd integer multiples of pi by 2. So option C is the correct answer. Here is your question number 5. Don't forget to pause and give it a try. In question number 5, the function is defined as the greatest integer function, or the third bracket of x. The graphical representation of the function is something like this. That means for all the integer values lying in between 0 and 1, the function is defined as 0, or the value of the function is 0. If the x is lying in between 1 and 2, the function, or the value of the function is 1. For the values of x lying in between 2 and 3, the value of the function is 2. Simply, when the value of x lies in between -1 and 0, the value of the function is -1. Then for -2 to -1, the value of the function is -2, and so on. So at each and every integer value of x, the function is discontinuous. In this question, we need to find the value of x out of these 4 options where the function is continuous. So from the graph, we can clearly see that for x belongs to integer, the function is discontinuous. So out of the 4, all 3 are integers. So at -2, 1 and 4, the function is discontinuous. Only option D is not integer. So at point 1.5, or for x equals to 1.5, the function will provide a particular value, and that value will be 1, because for x lying in between 1 and 2, the value of the function is 1. So that means option D is the correct answer. Question number 7 to question number 18. All these questions are of same type. In this particular type of questions, the definition of the function will be provided, and it will be told that the function is continuous at any particular value of for x. In the definition of the function, there will be 1 or 2 unknown constants. We just need to find the value of that particular constant for which the given function is continuous. For example, let us consider question number 11. In question number 11, the definition of the function is not provided directly. It is provided in terms of language. It says the value of the function f at 0 is unknown, and the value of the function for x not equals to 0 is given like 2 to the power x minus 2 to the power minus x whole divided by x, where for x not equals to 0. And the definition of the same function for x equals to 0 is unknown. Let us assume the definition of the function, or the value of the function, as k for x equals to 0. So this is the complete or modified definition of the function in question number 11. It says that it is continuous at x equals to 0. We just need to find the value of k. Now, in this type of questions, we will use the condition that left hand limit, right hand limit, and the value of the function at that particular point C will be equal. Only then the given function will be continuous at C. In this case, the point C is equals to 0. Now, f of 0 is directly k from the given definition of the function. Now, left hand limit or right hand limit, we can calculate any of them as limit x tends to 0 plus or minus for LHL and RHL respectively fx. Now, if x is tending to 0, then x is not equals to 0. So we will use the second definition of the function, that is 2 to the power x minus 2 to the power minus x whole divided by x. Now to simplify this, first we will convert this or simplify this in this way: 2 to the power 2x minus 1 divided by x into 2 to the power x. We have multiplied numerator and denominator with 2 to the power x. So the first term will become 2 to the power 2x, second term will become 1, and the third term is x into 2 to the power x. Now we can use identity or formula from limit algebra, which says a to the power x minus 1 whole divided by x is equals to 1, and we will keep it the 1 by 2 to the power x separately. So after applying the property, we will get the log of 4 into 1 by 2 to the power 0. So final answer is log of 4. So this is the value of LHL or RHL. Since the function is continuous, so LHL or RHL will be equal to f of 0, that is k. So therefore k is equals to log 4. The last important type of question from this chapter is to check the differentiability of any function at any particular point, or for the range of x where the function is either differentiable or not differentiable. For example, consider question number 19. It says the function is defined as fx is equals to mod of x at x equals to 0. Which of the following 4 options is correct? Now, if the definition of the function is fx is equals to mod x, then the differentiation of the function will be x by mod x. This is the direct formula to differentiate the modulus function. Now in this case, or in the expression of first order derivative, there is something in the denominator, and that factor is mod of x. Now if we consider x is equals to 0, then f dash x is going to be undefined. Not exactly undefined, it is going to be indeterminate form 0 by 0. So we can't differentiate this given function when x is 0. So at x equals to 0, the function is continuous, but it is not differentiable. So in this case, option A is the correct answer. Let us consider another example of same type. Question number 28. It says the function fx is equals to mod of sin x. We need to find where this particular function f of x is equals to mod of sin x is continuous but not differentiable. So in the same way, the differentiation of the function will be sin x by mod of sin x into derivative of sin x is cos x. Now again, the denominator contains sine of x. Now we know that for sin x is equals to 0, the solution x is n pi, where n is equals to 0, 1, 2, all the positive integers. So in this case, the option B can be the correct answer, which says f is continuous everywhere. Sin x function is continuous for all the real values of x, but not differentiable at x is equals to n pi, n belongs to z. So option B is the correct answer. Try to solve the remaining sums of the PDF and let me know in the comment section.